I have the pleasure to introduce our second speaker of this session, Dr. Diana Kemmer, also from the Fraunhofer Institute, and she's going to focus on safety assessment of circular PET packaging. The floor is yours.
Okay, good afternoon, everybody. Thank you very much for the kind invitation to talk here today. The topic I will focus on is the safety assessment of circular PET packaging. A short glance at the agenda. I will briefly touch the EU policies on plastics in food packaging and recycling. And I will focus on a comparison for how virgin PET and recycled PET are treated in Europe with regard to the legislative demands. And as a third point, I would like to present to you how the safety of recycled PET materials are being assessed. We've heard in the morning session about the European Green Deal, about Europe's very ambitious plan to transform its economy into a circular economy, which shall reduce, of course, the pressure on our natural resources, create a sustainable growth, to halt biodiversity loss, and overall to help to achieve our goal for climate neutrality. And thinking about plastics, these general goals are also being reflected in the EU plastic strategy. So no questions, plastics are a very important material in our economy, in our daily lives, and we all use them, and they serve ideally for very different purposes. But at the same time, we know that they do have negative effects on the environment and on our health. And the EU plastic strategy is also aiming to strongly reduce plastic waste. This is either by avoiding unnecessary packaging, also by limiting overpackaging, and also by boosting reuse and recycling. And in the morning we have learned that there is a prioritization of these aims from reducing it to reusing it to recycling it. And we've done recycling for many decades. But this is strongly enforced now to upscale recycling in our economy. So in an ideal world, it would be possible to close the cycles, which means that we can use a recycled material and bring it back into its previous application, or at least in a similar one. What we do not want is this downcycling to products, to items which are less valuable. At the same time, the EU recycling regulation, and also the previous one, strongly emphasizes food safety. When new food contact materials are made from post-consumer recycled materials, these materials must be safe. And this is a potential conflict of aims, or at least a challenge. So let's have a look how virgin PET is treated in comparison to recycled PET when it is used for food contact materials. First, and the most important piece of legislation I would like to present to you is the European Framework Regulation. I guess you've all heard about that, and the general requirements which were set in Article 3, that those materials and articles may not transfer their constituents into food in quantities which could endanger human health. That's the most important demand. And of course, they may not bring about an acceptable change in the composition, and they shall not change or negatively affect the organoleptic characteristics of the food. But of course, human health is the most important demand. So thinking about the European Framework Regulation, it's important to notice that it applies to all and any kind of materials that are brought in contact with food. So as a consequence, these very basic safety demands apply both for virgin and recycled polymers when they are used in food contact applications. So how are virgin materials, well, we are focusing on PET here, of course, being assessed, and how is this quality and the safety assured? So we start off, of course, here with the European Plastics Regulation 10/2011, which is a piece of regulation which is giving more details on how to achieve this article-free demand of having a material which does not harm human health. So in this regulation, we have the Annex 1, which is a positive list, and it lists substances like monomers and additives which may be used in the production of the PET material. As I said, it's a positive list, so as a consequence, substances which are not on that list may not be intentionally be used. Several of the substances listed there have limits which we have to obey, specific migration limits which are set, which are derived from the toxicological properties of the substances. And the compliance with these limits is checked by specific migration tests of these substances which are subject to an SML, either by the end of shelf life, or we are using enforced migration conditions like testing for 10 days at 60 degrees, which is kind of a translation of the real-life application into test conditions. Typically, we have also a statement on non-intentionally added substances, which are typically found in virgin PET. So producers and scientists have a long time experience on what kind of substances we would typically expect to be present in a virgin PET. And the compliance assessment or a compliance statement will therefore be either based on these experimental migration testing, but also diffusion modeling can be used to show this compliance. And taking into account this whole situation, testing at regular intervals is completely sufficient for this kind of compliance testing. So why does this concept, which works well for the virgin PET, does not really work for recycled PET? First, we have in the recycled PET a large number of substances which are basically unknown. So these substances are possibly, or there are different possible sources. First to mention is or are post-consumer substances which originate from the original fillings. Okay, these substances will be there, not avoidable. There may be cross-contamination from the recollection system. So the food packaging, the PET bottle may come in contact with other fillings from other packages which are collected together. We should also not neglect the cross-contamination with substances from the packaging materials, which could be labels and glues and closures. Also, during the recycling process, there may be a degradation of additives on the polymer itself, which leads to newly formed substances. And last to mention is also the misuse of the PET bottles for the storage of non-food liquids, thinking about any kind of solvents, household or garden chemicals. So in an overall view, we have here a very large pool of substances with not really well-defined identities. Secondly, we have the situation that the residual concentration of these post-consumer substances are not well known. The concentrations may depend on various factors, like the recollection system. Do I have a curbside collection, or do I have a deposit system, bringing, for example, the PET bottles into a collection system? Also important is the concentration of the input, or the concentration of these substances in the input of the recycling processes. Possibly I have flavor substances which originate from flavored drinks, so they will be there, which is a kind of a typical situation. I could also have contamination from misuse of the bottles, which should not happen so often in comparison. Of course, we have the influence of the cleaning efficiency of the washing process, the conventional recycling step. This is always the first step in the recycling process for food-grade PET. And we have, secondly, the cleaning efficiency of the deep cleansing process, which is also called the super clean recycling technology or process. So, bringing that together, for the virgin PET, we know there's a lot of knowledge. We well know the target substances which are in the material. We can measure them with targeted methods. And in contrast to that, we have this large pool of post-consumer substances which are potentially present in the recycled PET with an unknown nature and unknown concentrations. So, as a consequence, we cannot use these specific migration tests, but we would have to use non-target screening analysis, so which are, of course, a lot more challenging. And thinking about the analytical challenges, we would also think about the detection limits which we have to achieve to ensure in an analytical control that we can also cover potential genotoxic substances. So, as a consequence, recycled PET should be tested or analyzed with a higher frequency. But it's also good to know that in the recycling polymers, we have quite a number of well-known contaminants, which we then can also use to measure by targeted methods. So we have over 20 years, maybe I could have written 30 years, of experience now in knowing and examining post-consumer substances in recycled PET. So what makes PET recycling, especially or predominantly the bottle-to-bottle recycling, so attractive? So basically, PET bottles are on the market worldwide in large quantities, even though we've heard about the problems of quantities this afternoon. We have already established collection systems. The PET material itself contains only low amounts of additives. They are colored, but only in 3 colors, usually. And basically, all the PET material on the market which is used in packaging is approved for food contact. And maybe the most important aspect is relating to the diffusion characteristics of PET, as it is a low diffusion polymer, so it shows very little interaction with the filling material. So how are those recycling processes, which are established, being evaluated? This brings me to the key question. So I have my food-grade package. I use it, I fill it. It is being recollected, recycled, and reprocessed, and we have a newly produced package. And the question is, I possibly introduce unwanted toxic substances, and the final question is my newly manufactured packaging safe? Is it food grade again? And for this question, the EFSA, European Food Safety Authority, has made consideration and defined criteria. And they were published in this scientific opinion back in 2011. And I would like to present to you next the basic criteria which make up, which are considered in this safety evaluation. So the first aspect which is being regarded is the contamination in the input material. It's important to know what is the level of contamination in the washed flakes, so after this first washing step. Are there any genotoxic substances detectable, because they are of the highest concern? The second aspect is how is the cleaning efficiency of the recycling process we are using. So this is being evaluated typically by a challenge test where you have a artificially contaminated input material. The contaminants are selected chemicals, and the cleaning efficiency is calculated comparing the concentrations before and after the recycling process, which gives room to the optimization of the process. The next aspect is concerning the exposure of the consumer. So we typically evaluate different consumer groups, and for these consumer groups, then tolerable or acceptable maximum migration values are derived. And as a last step, we will also use the calculation, so mathematical or diffusion-based modeling, to calculate what maximum concentration would be acceptable in the packaging. And here also the development or further development of these diffusion modelings are going on, as the currently used models are quite overestimative, and we have some less conservative but more realistic prediction models already available. So, okay, this brings me to this general assessment of the evaluation criteria. I already mentioned that you start off with the worst case contamination in the input material after the first washing step. You consider the cleaning efficiency from the challenge test, and then you come to the exposure assessment. And as I mentioned, we look at different consumer groups. Typically, it's infants, toddlers, and adults. And from these three consumer groups, we can calculate a maximum migration value for a specific application. So we take the specific consumer group, we take the specific filling good, and the shelf life, which is considered here. And also, well, the consumption behavior goes in here. So the diffusion modeling is used to calculate or transfer this value into what is being acceptable in the packaging article. And at the end, we compare this residual concentration of the contaminants to these maximum acceptable concentrations. Another important aspect is the input control. So I mentioned that you have to have a well-defined input, and so the best choice is to have, your input material should originate from food grade. Labels, glues, and closures should be eliminated in a very early stage of the recycling process. And at the end, we have said that about maximum 5% of the PET bottles which go into the recycling process may be from non-food applications. So this is 5% for PET. For HDPE, it's a maximum of 1% established. So for these input concentration I was just talking about, EFSA has set for the PET bottle recycling an input concentration of 3 milligrams per kilograms, as a worst case. And we've also seen this exposure assessment that 0.00525 micrograms per kilogram body weight per day are being judged as a neglectable risk presented from an unknown chemical. And this value is coming from the TTC concept and also includes genotoxic substances. So let's take one of these exposure scenarios, an infant with 5 kilogram body weight that drinks 750 milliliters of water per day from such a PET bottle, which is made from 100% recyclate. And if you make up the calculations and also consider the overestimative character of the migration models, this leads to a maximum tolerable migration of 0.1 micrograms per milliliter. If you make up the calculation for toddlers and adults with different body weights and consumption behaviors, you come to slightly or significantly higher acceptable migration limits. So you cannot ensure that from a bottle-to-bottle recycling that the drink will be only consumed by adults. So for PET bottles, the values for small children, in fact, apply. And for the migration modeling, it's important to know that the contact conditions of 1 year at 25 degrees Celsius are being used. So if that was a little bit theoretical, maybe we have a look together at this illustration. This figure graphically shows this stepwise approach. So we start off on the bottom right with this 0.0025 micrograms per kilogram body weight per day, so which is the acceptable intake or tolerable intake from the TTC concept, which is being transferred into a concentration in food for these different consumer groups and reflecting the body weight and the consumption behavior. So from here, we use diffusion modeling to calculate back what would be an acceptable concentration in the PET packaging item here in the PET bottle wall, which brings us to different acceptable concentrations for these different age groups. So if this concentration which we receive in the PET bottle after applying the super clean recycling process, if this concentration is below the concentration which would be defined as being tolerable, then the recycling process is being judged as safe. So we can also reflect these results in a assessment of the minimum necessary cleaning efficiency, depending on the molecular weight of the potential contaminant. And here you can see that this vastly depends on the different storage conditions. So the packaging application, would it be a product which has a shelf life what would be tested at 10 days at 20 degrees, or do we go for longer shelf lives like 1 year at 25 degrees? And you can also see how the different consumer groups go into this calculation, comparing the red curve, for example, to the blue one. So if we take the situation here for the blue line, we have the most sensible application, infants, a storage time for 1 year at 25 degrees, which requires much higher cleaning efficiencies compared to, let's say, a PET to beer bottle, which would be only consumed by adults. So this is also being summarized in this table. You have the different applications like bottle-to-bottle, bottle-to-tray, or bottle-to-meat tray. You start off with the same worst-case input concentration for PET. You have the exposure assessment or tolerable exposure, including the CMR substances, and you come up to specific migration limits. So if we can exclude genotoxicity in those input contaminants, this would lead to a much higher migration, or much higher acceptable migration values by a factor of 600. So summarizing the situation, that for these mechanical recycling processes, over 140 recycling processes were evaluated by EFSA till now. And we will talk a little bit about the newly introduced aspects by the new recycling regulation. So I'm not going to detail here, but I would like to come to my final conclusions. So the EFSA assessment that I just presented to you is extremely conservative. This starts off with the assumed input contamination of 3 milligrams per kilograms and assuming that all of those post-consumer substances are CMR, which is a conservative assumption. Also, the migration model, which is used by EFSA, it's overestimative, the AP model. There are more realistic modeling parameters around. And this is not so much a problem for the PET recycling process because, as I mentioned already, it's a low diffusive polymer. It's quite very inert. And we've just heard that the situation is comparable to other polymers like polystyrene, which are also low diffusive polymers. So there's a good chance that this will work equally like the PET. But for highly diffusive polymers like the polyolefins, these strict requirements are almost not achievable. So there is still quite a lot of work to do, and we've also seen some of solutions in the talk of Professor Langowski that functional barriers could be an option here as well. Thank you very much for your attention.
Again, the reference level, do you think that it can be lowered down because things change over time and 20 years are a long time to, and again.
I guess it would be a good idea to reconsider the criteria. I mean, they were really good, I think, from the start, 2011, and even at that time, there was already a history of evaluating recycling processes and looking at those contaminants. So the criteria could be adopted, maybe they should, and it is, I would not call it questionable, but the input concentration, this is data which is coming from 2004, which was a really big study on the potential misuse and how many bottles may be misused in 1,000, 10,000, 100,000 bottles. So I guess that situation is not comparable today anymore.
Is the regulations and the pressure not going into the opposite directions and being more conservative and going to push for more, I would say, reducing limits and everything? So we see with the 15 amendments of the food contact, with insisting about this migrations limit now of 0.15 ppb, if you cannot exclude genotoxicity of any contaminant. So we see many things going rather to decrease the threshold. So you show it's conservative, but it's going into more conservatism.
I would not say that it's getting more conservative. The point here with the tolerable uptake of a CMR substance is more and more reflected in the plastics regulation, which was not yet reflected. So this is what you're mentioning, the 0.1. Oh, sorry. I think this is, it's a little bit the other way around. It was already included here, and now it's being transferred also into the plastics regulation, focusing on CMR substances and the NIAS aspect, which we are referring to. Yeah. So for the plastics regulation, yes, it is getting stricter, shifting from the 10 ppb for non-intentionally added substances to potential CMR substances, but this aspect has already been included here back then. Okay, if there are no more questions, we will have this dinner and we will see us tomorrow. If there are any more questions, don't hesitate to come to me and to ask. Thank you.